use this unless you go into a high power research lab that's looking at clinical studies. So, how do we measure? I'll get Pooh Bear to help me out here. So I could take this out and measure it, right? And this was actually done once, I think, in the 1600s with a horse. But patients don't respond well to this kind of approach, do they? No, they don't. Okay. So, is there another way we could do this? I weighed out 10 milligrams of blue stuff, actually Evans blue. Oh, and yes, it does stain. Yeah, this was a brown jacket before. So I can inject a dye and we're allowed to do this with patients, right? I can measure the blueness, the concentration of the blue. So how does that help? Oh, wait a minute. What am I looking for? A volume. Volume equals mass over concentration. Well, I told you it was 10 milligrams, right? And I can measure the concentration, so I can measure the volume by the dilution principle. Okay. So it's pretty straightforward. As I say, you will never do it, but you can almost guarantee that the shelf exam will have a question that asks you to be able to do this, okay? And so that's why we have to do it. Sometimes we just have to suck it up and do what we're told, yes? But you've been doing that for a long time now, haven't you? So you're used to it. Okay. So all we have to do is find something that distributes in the space that we want it to and measure it by dilution principle. So if we wanted the total body water, we'd have to find a substance that distributed through all these compartments. If we specifically wanted the ECF, we would have to find something that would distribute into the ECF but wouldn't get across the membrane. Okay? So we just need to find a particular marker. And I wasn't being smart with this Evans blue. The Evans blue that I used here is actually used to determine plasma volume. So there is a table there, and I will write them up. So markers for total body water include antipyrine, or tritiated water or deuterated water. So basically water moves across the barrier, so anything that's labeled. Tritiated is a radio label. Deuterium is not a radio label, but it is an isotope, and it changes the density of water, so you can determine how it distributes. What's next? ECF? Probably the first one on the list is inulin. We need something that doesn't cross the barrier. Inulin gets across the capillary, but it doesn't get inside cells, okay? And then there's a whole bunch of things, a whole bunch of solutes, and probably radio-labeled sodium, radio-labeled sulfate, thiosulfate. What else do I have listed there? Oh yeah, mannitol. Mannitol in many ways very much like inulin. So I know it's frustrating for you guys. I know you want to do some doctoring and you say, gosh, I have to remember all these silly compounds. Yeah, afraid so. They do expect you to understand how some of these compounds distribute across these compartments, okay? And then there's plasma, and I've probably got Evans blue and radio-labeled albumin. Makes sense? Doesn't cross the capillary. The Evans blue binds to the albumin, and so anything albumin doesn't get outside the plasma, and so it measures this compartment volume. And if you want to know any other compartments, you'd have to do them by subtraction, and that's listed down here. So I mentioned earlier that these markers are not perfect, and they're kind of estimates because this 2/3, 1/3 may not be totally accurate, and so sometimes they're just referred to as the volume of distribution of inulin or the inulin space, and you're supposed to intuit that that's an index of extracellular fluid volume. Okay? So to be more practical, stuff you will never need to know beyond your undergraduate years. How do we do these calculations? Because you can be sure that there's going to be a test question, certainly on my test, and almost certainly very likely on the STEP exam. So how do we actually do this? Well, I've already described what's that tapping noise? Now that is going to irritate me. Oh, and you're looking at me and saying, yeah, it's already irritating me. Is there anything I can do about it? Okay. And let me take some numbers in the Mr. Good case too. I think this was Mr. Good, or was this Costanzo? No, this is Mr. Good. Costanzo actually does a problem on page 252, but it's kind of the same way. With Mr. Good, we gave 10 grams of something, and I can't remember what it was. So if we're looking at this, we're looking for a volume. So we're looking for a volume, and over there it says it's mass over concentration. Okay. So we could measure the concentration, that's not a problem. But they want you to do something, with this mass. So the way they phrase this is, we gave 10 grams, and at the time that we measured the concentration, 3.3 grams were excreted in the urine. It's kind of trite, but what they want you to reason is that if 3.3 grams came out into the urine, you got to subtract that and get a value of what, 6.7? So the value that you would feed in here would be 6.7. I go through it in the Mr. Good case, but I just thought I'd give you a heads up. Like I said, the whole thing is trite because there's no way you could